So picture this. It's the 1920s. You're a guitarist in a big dance orchestra,
Mm-hmm.
and you have this huge problem. You're surrounded by blaring horns, pounding drums, and your little acoustic guitar. Well, it's just completely lost. You can't hear it at all.
Right, you're basically just part of the rhythm section visually at that point.
Yeah.
The problem was simple. Volume. Just had to get louder.
Exactly. And the solution that a luthier named John Dopyera came up with was pretty radical. He invented the resonator guitar.
And that invention was, the single biggest leap in guitar volume before electric amplification came along and changed the game completely.
So for today's deep dive, we're going to get into the physics of that sound, that really distinctive, loud, metallic sound.
Yeah, let's break it down.
Okay, so a normal acoustic guitar, the strings vibrate a wooden top, the soundboard. The resonator just throws that idea out the window.
It does. It completely rethinks the engine. Instead, it routes all that string energy through the bridge directly to these spun metal cones.
And these cones act as transducers.
Exactly. And what we mean by a transducer here is, well, it's a device that's just much, much better at turning the string's vibration into sound into moving air than a piece of wood ever could be.
So it's more efficient.
Way more efficient. The cone is built almost exactly like an audio speaker. There's a central point that gets pushed and pulled, and the whole thing moves like a piston.
And the material is key here, I'm guessing. It's not wood.
Not at all. It's typically very thin aluminum, maybe 0.010 inches thick. It's light, it moves easily, and it's perfect for this job.
So you're trading the warmth of wood for the raw efficiency of metal.
Precisely. But here's the brilliant part. The design wasn't just about making the strings sound louder. It was engineered to add its own voice.
Yeah.
To be deliberately noisy.
Okay, what do you mean by noisy? That signature metallic sound.
That's the one. It comes to these very strong frequency peaks that are not the natural harmonics of the string. They're extra notes, basically.
The cone itself is singing along in a way. It must have its own resonant frequencies.
It absolutely does. And the key difference between aluminum and wood is something called damping. Wood naturally absorbs and quiets vibrations.
It has a warmer, shorter decay.
Right. Aluminum has very little internal damping. So when the cone resonates, those extra non-harmonic frequencies are super sharp, they last a long time, and they just cut through everything.
That's the clang, the sustain. Okay, that makes sense. Now, not all resonators are the same. Dopyera's company, National, came up with 3 main designs.
First was the original, the tricone. It actually used 3 smaller cones.
Which gives it a smoother, more complex sound, right?
A bit more detail. Then came the single cone biscuit design. It's called that because of the little wooden biscuit that connects the bridge to the cone.
And that one is aggressive. It's louder, has a really sharp attack.
The sound of Delta blues right there. That's the one.
But there's a third one, the Dobro style. The single inverted cone spider.
The spider.
Right.
It uses a different bridge system that looks a bit like a spider, and it pushes on the rim of an inverted cone. It was cheaper to make, and frankly, even louder.
It's amazing how these tiny structural changes create such different tones.
It is. Even the body material matters. A steel body is going to be punchier and louder, where a brass body might be a little warmer.
Which brings up a question. If this was all about being loud with metal bodies, why did the wood-bodied Dobro, the spider bridge design, become the sound of bluegrass, a genre all about acoustic tone?
And that's the final piece. The metal-bodied National was perfect for the raw, percussive style of blues. But the wood-bodied Dobro gave you that volume with a warmer sustain that was perfect for fast, clear finger-picking lines.
So the tool was optimized for the job.
Every time. And, optimizing complex systems, whether it's for sound or for business, it always takes that kind of deep analysis.
Speaking of which, this deep dive is sponsored by Silk. If you need help figuring out where AI agents could make the biggest impact for your business, everything from AI training to automation and software development, you should check out embersilk.com.
In the end, the Resonator survived the electric guitar because its tone wasn't just a gimmick. It became essential. It found its home.
Which leads to this one last kind of mind-blowing thought for you to take away.
Oh, this is a great little piece of history.
The resonator tone is so similar to a modern loudspeaker cone. And it turns out that in the 1930s, a speaker designer named Jim Lansing.
Yes, that Lansing of JBL fame.
He started using a spun metal cone design for his theater speakers that was almost identical to the Dopyera's design.
So it leaves you with this fascinating question to think about. Did this acoustic instrument built to compete with bands, end up inspiring the very electric audio industry that was supposed to make it obsolete.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.